Space is a vast, partially unexplored expanse, and in it, one can find numerous objects varying from planets to stars, comets and asteroids, and even forces that defy physics and all that we know. For thousands of years, astronomy has been a commonly studied field in science, dating back to the ancient Greeks and Babylonians and the Chinese. But over time, the study of the universe has evolved tremendously. There are mysteries within the cosmos, invisible forces that captivate researchers all over the world. One of the most curious finds by astronomers and the physicists is a force so powerful that not even light can escape its grasp. But to understand the principle of black holes, one must understand what they are, how they came about, and their anatomy, and the types of black holes that exist. To start off, what are black holes? Well, a black hole is a collapsed star with a large enough mass but small volume that produces such a strong gravitational force that nothing can escape it. Contrary to popular belief, black holes do not act like vacuums that suck anything into it. A common explanation goes as thus. If our sun were suddenly replaced with a black hole of the same mass, Earth's orbit around the sun would remain unchanged. Of course, Earth's temperature would change and there would be no solar wind or solar magnetic storms affecting us. Although we would not be able to be sucked into the black hole, life on Earth would of course be impossible. To actually be sucked into a black hole, one has to cross inside the Schwarzschild radius. And while no light or matter that falls into a black hole can escape, it can heat up the area around it. Researchers see this as radiation and on X-rays that allow astronomers to conclude the presence of some powerful and invisible force, what they call black holes. Named black holes by John Archibald Wheeler in the 1960s, the idea of the existence of black holes was first hypothesized to exist sometime around 1783 and 1795. John Michell, a British astronomer, concluded that matter and light were affected by gravity. He went further into his explanation by stating that an object with a density and mass 500 times greater than our Sun would exert a gravitational pull so great that all light emitted from such a body would be made to return toward it. Due to the immense gravitational pull, light would not be able to escape, making the object invisible to the human eye, even with the aid of a telescope. Mitchell called this object a dark star. The second man to propose the concept of a black hole was a French physicist named Pierre-Simon Laplace. He came to the same conclusion in 1795 and stated, "It is therefore possible that the greatest luminous bodies in the universe are on this account invisible." Both scientists' opinions and beliefs opened a whole new view of scientific exploration in our universe. Next, how are black holes formed? There are many theories suggested by astronomers on the formation of black holes. A common explanation presented to describe the forming of a black hole is based on the death of a star that has nearly entered its supernova stage of life, where it can no longer produce enough nuclear fusion, resulting in it not being able to provide enough heat and energy for nuclear energy consumption. This causes the star to lose its pivotal balance, as it can no longer produce enough electromagnetic radiation to maintain equilibrium with its inward pull of gravity. Eventually, its own gravity collapses in and on itself. Up until now, astronomers believe that there are 4 types of black holes, and more could possibly exist. First, stellar black holes. Stellar black holes can vary in size, but usually have a quantity of 4 to 10 solar masses. There are supposedly millions to trillions of stellar black holes, varying in sizes all over space, and they consume many planetary objects. The largest types of black star are called supermassive black holes. They have a solar mass millions to billions times larger than that of our Sun, found at the center of many galaxies, and surrounded by dust, stars, and gas clouds. Believed to have been formed during the explosion of the Big Bang, the miniature black hole is believed, if existing, to have an event horizon no larger than the size of an atom. And yet, even with such a small size, it has as much matter as Mount Everest. The term wormhole is most often associated with the idea of space-time travel, usually promoted in fiction movies such as Star Trek, Star Wars, and Farscape. And yet, Einstein himself realized that a bridge between 2 points in space could exist. Called Einstein-Rosen bridges before being dubbed wormholes, they hypothetically act as a crossway between 2 areas of distant space. Wormholes are a hypothetical principle that allows a person traveling through it to move at a pace faster than the speed of light, And this is where Einstein contradicts himself. If nothing is faster than the speed of light, then in theory, wormholes cannot exist.